Alright everyone, welcome to the stream. Today I guess we're gonna be continuing on prototype illusion attacks, because this topic I think it does deserve more attention, because we briefly covered the tip of the iceberg on the last stream. So I actually picked up many different articles and content for regards to that topic. So I guess it will be more than enough to cover this. And for other people, I will probably also create the channel on our Discord where you can explore that vulnerability as well. It will be kind of guided walkthrough, but those are just for the subscribers mostly. And yeah, so far so good. Everything is alright, except my neighbors. They were kinda annoying today, I gotta say. So I had some problems, so if during the stream I get knock on the door, I guess that could be a neighbors, because these past days I had some issues with them. I'm not smoker myself, and they are actually one floor below me. They chain smoking every day, and they I live in the last floor apartment, and it's extremely hot, especially even in the autumn. And instead of using air conditioner, yeah, I can use air conditioner. I have air conditioner, but it will cost me huge electricity bill. So what it's better to do is just open one window at one side and other window on the other side of the apartment, and my apartment will cool down pretty quickly. But they smoking every freaking time, and it's getting annoyed, so I had an argument today. Yeah, so, and there are the laws, of course, for that. If the smoke is going to your neighbor's apartment, you have to pay some, fines for that. So I guess next time it will be, I won't be that friendly to them. Yeah, but I want to be a nice neighbor at first. I tried speaking them nicely, but when I try to be a nice guy, they just started shouting at me. So I don't want to hack their Wi-Fi. What I could just do, just freaking call the police, and they will pay some money because of that. It's up to them. They decided to be that kinda bad neighbors. So if I hack the Wi-Fi, yeah, I can do that, but I don't want to be a black hat. And yeah, even hacking the Wi-Fi is not gonna be good. Alright, so let me switch the screen and just continue to the topic. I selected few pretty good content. So the first thing we're gonna explore is Portswigger, their explanation about prototype illusion. We're gonna review one report on HackerOne. There are not so many reports about prototype illusion, so I just picked one. There is also pretty good security research, this article were mentioned in the previous stream about RC in Kibana. Yes, it's pretty old, but it's pretty interesting read. Or we can alternatively, we can also explore this video, which is basically explaining that report. We can really save a lot of time just watching this video. The Bug Bounty Reports Explained is really good channel, even though this video is 3 years ago, and back then the content quality was maybe not the highest standards, but still, he did really good job. He put a lot of effort. So probably we're gonna review the video. And the last article is how you can hunt for prototype illusion at a mass scale. So we're gonna check this article, because it also looks really interesting, just in case if you decide to do some kind of automation, you can get some ideas here as well. So yeah, this seems pretty interesting. The drawing itself is also cool. Alright, so let's maybe start with just a Portswigger description. Previously we have explored article, but he was just basically explaining in his own words like how everything happens, but we can like broaden the knowledge as well and review what Portswicker has. So what is the prototype pollution? Prototype pollution is JavaScript vulnerability that enables an attacker to add arbitrary properties to global object prototypes, which may be inherited by user-defined objects. And they have pretty nice infographic how basically the prototype pollution attack will happen. So it's just like user can create the object and it will be polluted, like poisoned or something. So yeah, those are like multiple not events, like functions happening inside the website itself. Yeah, so let's continue reading. Although the prototype pollution is often unexploitable as standalone vulnerability, lets an attacker control properties of objects that would be otherwise inaccessible. Yeah, so this is really good point. Like on the previous article we learned that mostly there will be just vulnerable libraries on the JavaScript, like not plain JavaScript will be affected, but mostly the libraries it uses. But like if you have developed something using JavaScript yourself, you will probably know that every freaking day the new library is coming up into the industry, and there are so freaking many libraries, and it's really a huge attack surface. So as they usually exist in the libraries itself, this like particular vulnerability, it's pretty interesting. All right, if the application subsequently handles an attacker controlled property in an unsafe way, this can potentially be chained with other vulnerabilities. In client-side JavaScript, this commonly leads to DOM XSS, while server-side prototype pollution can even result in remote code execution. Yeah, we're gonna explore this one. I guess this video will do better. If you are unfamiliar with how prototypes and inheritance work in JavaScript, we recommend reading the following overview before continuing. We can check if something new, if we discover something new, we can probably read, but it's just basically explaining the same thing that we have already knew if you followed previous stream. So yeah, so there is like they are just showing that there is multiple ways how you can pollute like different like it could be object, it could be string, array, number, different types of prototype pollution. So yeah, those are like things, and there is even labs where you can even practice yourself. I guess we're gonna just explore theory. If we have time, we will like try to play with some labs maybe, but I guess it will be already a lot of information to like cover. So let's maybe continue. How do prototype pollution vulnerabilities rise? So it's basically just polluting. Let's explore this one. Probably this one will be more interesting. A prototype pollution source is any user controllable input that enables you to add arbitrary properties to prototype objects. And as we've seen before, there is like could be different like object, string, arrays, or numbers that could be polluted. Most common sources as follows. So like the most common way is via URL, via query fragment using hash. It could be via JSON based input or web messages. We haven't actually explored those two, so those I guess via URL will be the most common ones. So for example, via URL you can like create evil property and assign the payload. So the payload will be for example XSS, DOM based XSS. It depends how this property will be polluted and if that property will be used somewhere in the application. When breaking the query string down to key value pairs, the URL parser may interpret proto as an arbitrary string. Let's look at what happens if these keys and values subsequently merged into the existing object as properties. You might think that the proto property along with its nested evil property will just be added to the target object as follows. Alright, however, this isn't the case. At some point, the recursive merge operation may assign the value of evil property using statement equivalent as the following. During the assignment, the JavaScript engine treats proto as getter for the prototype. As the result, evil property is assigned and returned to a prototype object rather than the target itself. Assuming that the target object uses default object prototype, all objects in JavaScript runtime will now inherit evil property, unless they already have property on their own matching the key. But if it's like empty like function, empty object, empty string or number, well, yeah, it could be like it could get polluted property. In practice, injecting a property called evil property is unlikely to have any effect. However, an attacker can use the same technique to pollute the prototype with properties that used by the application or any imported libraries. So yeah, there is other way how you can pollute via JSON input. So I guess if you're just like using the JSON value name as the proto and then like injecting evil property into it, like this is one of the way. And if somewhere in the JavaScript it's just using JSON parse, that could be achieved as well. So a prototype pollution sinks. The prototype pollution sink is essentially just a JavaScript function or DOM element that you're able to access via prototype pollution, which enables you to execute arbitrary JavaScript or system commands. Yeah, system commands. We've covered some client-side things extensively in our topic DOM XSS. Yeah, so these are very closely related to DOM XSS. Feel free to explore like what are the let's call them dangerous functions. Sinks are just basically dangerous functions where the user data will end up. So you have to look for those when you're like exploring the possibilities for prototype pollution. As prototype pollution lets you control properties that would otherwise be inaccessible, this potentially enables you to reach number of additional things within the target application. Developers who are unfamiliar with prototype pollution may wrongly assume that these properties are not user controllable, which means there only be minimal filtering or sanitization in place. Okay, let's see. Let's maybe we can explore those, but those are mostly like already checked by previous article. If you want to like learn even more, you can try read those yourself as well. So if you haven't understood a lot of things on the previous stream, you can feel free to explore those. But let's see like how vulnerabilities arise. This is also really interesting area to look at, because you have to understand where usually you want to look for those vulnerabilities, just in case you are like interested in exploiting that. So the prototype pollution vulnerabilities typically arise when JavaScript function recursively merges into object containing user controllable properties into the existing object without sanitizing the keys. This can allow an attacker to inject property key like proto along with an arbitrary nested I think I read that. Okay, yeah, I think I already read that. Come on, why I'm repeating. So yeah, basically we just like covered the base things, like the base ways how you can do that. We can check also the labs which this do actually cover. There are a lot of them actually, but like client side, DOM XSS, server side, even server side. I think they are pretty up to date. I really like Portsvigger Academy. They have a lot of up-to-date vulnerability. So prototype pollution is not that common, but it's really interesting. It's really interesting for sure. Okay, server side prototype pollution. Yeah, this is kind of advanced technique what you can do, but we won't go into that depth today. Let's maybe explore other sources for sure, because firstly I guess we just need to check all the like available content in regards to this topic, and then we might choose what's like the most interesting to us. So let's see the report, like what other people are also submitting. So it was found on the HackerOne itself, so it's kind of interesting. So the HackerOne itself use marketing. Oh no, the HackerOne marketing side uses Vistia to host and embed videos using HTML snippets similar to the following. So yeah, they just use the HTML code with some script tags, as we can see, the JS, and we just embed videos. Yeah, they're just using this product, not sure what it is, maybe it's just a library or something. Video marketing platform, let's see. Let's maybe use some little bit of Google if they have some kind of, or it's on the main page, not sure. Oh, it's on HackerOne. All right, so it's on the main website even, so that's kind of crazy vulnerability. The issue is that EV1JS script is vulnerable to prototype pollution when setting up logging via both URL and document referrer. So I guess they're just using this JavaScript code, and that library, probably, yeah, it's library. That library is actually vulnerable to that. So even the website itself is kind of safe, but they used third party, and that third party has some issues. All right, so the issue on this JavaScript code is actually kind of sanitized. I can see some JavaScript functions, but when I see variable names like that, it's actually that you can learn this, you can learn even reading this type of code, but what I like doing is just like copying some part of the code and throwing that into the ChatGPT and just asking just to create variables and or make it just more readable. I've seen other people using tools like Cursor or something like that, which also could help. Maybe there are even other tools. I think JS Weasel or something like that, but it's extremely expensive. I don't recommend like blowing thousands of like dollars just for one tool. That's crazy price for me, at least. So yeah, so you can use multiple, but you can just train yourself to like read this. Yeah, so if URL pass to IURL parse, so I guess to this function contains query parameter. So right here is our sync, no, not sync, the source. So the source is the area where the user input is coming from, so this will be URL parameter. So proto, and then you uses dot, and then like creating the value of like the function, and it's just assigning one. So when it filled up, on the object prototype, for example, visiting hacker1 blog, scaling security, blah blah, and then using proto, just using other example, like you can use the dot or you can try to use those, and he's just assigning AAA, and then typing object prototype in the console will show you the new property GGG. Okay, actually right now I cannot reproduce because I think they already fixed that. When initializing the embeds, the script creates elements using method from object that takes a hash from property students into new element. Okay, script elements using. Okay, if we use prototype pollution to add inner HTML to object, and when it's iterating over the hash keys, it will find inner HTML and set to newly created element. This will create an element with our HTML with a few extra parameters to prevent the script from erroring too early. It will also be added on the DOM, to the DOM. Okay, he also added the CSP bypass. All right, this is pretty good report because like he's chaining multiple vulnerabilities here. So this allows for arbitrary HTML to be injected, but due to CSP, inline scripts are blocked. The CSP does not allow Cloudflare to be used as the script source though, which means that AngularJS can be loaded into the iframe with source doc and be used to bypass the CSP. Okay. Yeah, so he's just using AngularJS right here, and then he's just using alert function. That's kind of crazy. Okay, so finally the most interesting part for us is how to actually reproduce this problem. So he's created the whole payload right here. So I guess he polluted prototype like this to like inner HTML function. That inner HTML function is being used somewhere, but he just needed to find the place where this is used. But he's just like created the iframe. I guess he was also testing for other stuff, but he just polluted this. What we can do is actually use ChatGPT to explain this. Let me quickly check. Oh, come on. I will just quickly use ChatGPT just for like explanation, explaining this part. It will be way easier for me just to deconstruct everything. Okay, the payload you provided is a complex XSS attack that uses vector that uses an iframe with source doc with inject AngularJS and the script. So it's just using with CSP bypass. That's kind of cool. It leverages AngularJS expression to alter DOM and potentially extract sensitive information. So it uses onError, but it uses Angular onError handler inside the image, and it also uses base 64 encoding, just maybe if there is some kind of WAF protection. So it's extremely smart exploit, I gotta say. It uses view a top right here. He's just using base 64. You can use base 64 decode maybe right here. Let's try to decode it, what is going on here. Oh, he's even using the style tag. He's using payload of the style, and then he uses href function. Okay, there are a lot of things going on here actually. So yeah, but it's basically just injecting HTML with some JavaScript payload, and that JavaScript payload also uses AngularJS function. So it's a lot of things to grasp actually. Okay, so the impact here, phishing attacks. If you logged into HackerOne and visit HackerOne and be directed to the dashboard, Chrome doesn't allow you to show the blah blah. Depending on how Drupal is set up, it may be possible to target the logged in admin, use access to load admin modules, install malicious plugin. Yeah, but I mean, steps to reproduce. He lost a lot of bounty because of this. I imagine the treasures of the HackerOne saw this report. Prototype pollutions are not that common, so like usually the security analyst may not like seen that many reports, and some of them might not know about this vulnerability, which could take some time to reproduce. And like one thing I see what he is lacked is actually showing more the impact, how you can execute the XSS, like more screenshots, and like only one step to reproduce. Not sure. Maybe with reflected XSS this is alright, but I think if he spent maybe 1-2 more hours, because he on the payloads itself I see he spent a lot of time, but if he spent maybe little bit more, like chaining with more vulnerabilities, he could have easily increased the final severity for sure. But he's just basically shown what you can like spin those. All right, so that's not enough impact, at least for me, with like this payload. If you found other area where that inner HTML is being used, maybe that could be in like higher bounty. I think like 500, don't get me wrong, $500 is alright bounty, but I think he missed quite a bit. So yeah, but this was pretty interesting for sure, I gotta say. Okay, and it's actually $250 for each, because 2 people actually did this. All right, that's pretty cool. Right now I guess what we can do, we can also check how you can hack not only client side, but how you can actually hack the server side as well. And there was like really interesting security research made on Kibana. So let's maybe review the bug bounty reports explained video about that.
In today's video, I will show you how prototype pollution attack led to remote code execution in Kibana. This is a relatively new attack, and it's especially dangerous in Node.js, which is growing in popularity.
Okay, let's see, 3 years ago, that was 2021. Yeah, I guess that at that time it was relatively new attack. The first time that attack was introduced, it was 2019, so 2 years maybe, for 2 years, but it was not widely spread. So yeah, in that case I guess it's
So that's definitely something you should learn. The video is based on an article by Michał Będkowski. He's one of the best in the world when it comes to JavaScript and client-side vulnerabilities.
yeah.
Links to his Twitter and to the blog post are in the description.
So let's see if it's using the same blog as we seen before. Yeah, that's actually the same blog. All right.
Enjoy the video. Even though JavaScript is not considered an object-oriented language, we can still define objects there, and moreover, there's an inheritance mechanism. So even if I create an empty object, it still will have a toString function, for example. And why is that? Because it inherited this function from the prototype. Because proto is an object that's by default a parent of any other one. So if I try to access a non-existent property or a function of an object, then the JavaScript interpreter will look in its parent for it. So in most cases, in the prototype, using it.
He's doing the like the basic explanation about JavaScript inheritance and things like that really well. I really like the amount of effort he put into this video. So basically, if we explore not the HackerOne report, but let's see, yeah, all labs, like right here, if we, for example, I closed that. If we explore the parts figure, the part about like inheritance, all those things, he summarized that really, really good in this video.
Syntax, you can access the prototype object and you even can modify it. And what's important, by modifying a prototype of one variable, you modify the prototype of all variables. So that's the concept of the prototype pollution. But how can this be exploited? So first, you need a way to somehow pollute the prototype, but then you need a piece of code that tries to access a non-existing property of some object so that the one from the prototype will be taken.
Not necessarily. You can actually target already existing properties, what's being used, as we've seen in like previous examples. But yeah, this could be one of the possibilities for sure.
And when this JavaScript code is being used on a frontend in the client's browser, probably most you can achieve is a cross-site scripting attack.
I mean, I see the not so happy smiley face emoji. Well, still, like, XSS could be as dangerous as server-side bugs for sure. If you can like steal a lot of data, get admin access to the most of the data, so it will be pretty equal, like not the same, but it could be a pretty severe vulnerability. In some cases, it could be critical for sure.
But when the application is written in Node.js, which uses JavaScript as a backend language, then you can use prototype pollution to achieve pretty much any server-side vulnerability, including remote code execution. Kibana is a piece of software written in Node.js that's used to visualize data from Elasticsearch. And Timeline Visualizer is a module which you can use to visualize.
I like that on his video he actually also included the screenshot how this look like. I'm not sure if on the original post. Oh, okay, never mind. They actually included that as well, but he's shown like his visuals are really, really good. Like I think he actually found the image or even tried setting up the lab himself. So like you have to appreciate the effort put into this video.
Time series. And you can write custom expressions to visualize the data. And using those expressions, you can, for example, set properties of objects. And polluting the prototype was the easy part here, and the hard one is how to turn it into the remote code execution. And while clicking through the application, the researcher noticed a lot of errors after clicking a canvas menu entry. They were about an address that was already in use. Such error appears when you want to start two services on the same port.
And also another good tip when you actually when you're actually hunting bugs for the application where you can set up yourself locally. In this case it was using Docker or something like that. What it's really good to do is also to do some kind of server side debugging. It will help you along the way for sure. Like if you like damaged and somehow damaged the web application, if you have the ability to debug on the server side what's happening, that will help you a lot. Like white box testing could be really interesting area. And usually if those products are being used across like multiple different targets, that could also be monetized. Like for like if you find the 0 day, then you can probably monetize. Yeah, there are some policies right now preventing doing that, but still there is like good possibilities to do so. And I think Kibana and like with Elasticsearch stuff like that are being used by like many companies. But I think for this vulnerability you have to be authenticated, so in that case, yeah, it's kinda like some things need to be prior to that, so not sure.
Spot 9229 on which a debugger was running, which means that Kibana was trying to launch a new service on this port, but it couldn't because of the debugger. And starting a new process is a functionality that has a lot of potential for RCEs. And there was a function normalize spawn arguments which managed environment variables for the new process. And honestly, to me, this function looks like a gift to someone looking for prototype pollution vulnerability. Because env property of options variable was undefined by default, which means that if the proto object would have this property, it would be used in this function. There are two ways to provide an argument to a new node process. One is using a standard argument, and the other one is using environment variable. So in this case, we could control environment variables, so we had the ability to provide arbitrary arguments to the new node process. And there is argument that seems like another gift for the researcher. It's called eval, and it executes its value.
Okay.
But turned out that it didn't work, because the eval parameter can only be provided using standard argument. Probably it's to prevent exactly the attack that the researcher was trying to perform. But thankfully, there's another option that could be used for this attack, and it can be passed using environment variable.
Yeah, we can already see like he's also showing his own terminal, and he's like trying to reproduce everything for himself as well. So you have to appreciate that, like the amount of things he gone through, like setuping all like this in his own computer. So yeah, that's kind of interesting.
Require. It can be used to import a file which will be executed straight away. But there is one problem: how to get a JavaScript file onto the server. In Linux, there is a file prod self environ in which the environment variables are being stored. And we can control the variables, so we control a part of this file. So we can use one variable to inject JavaScript code into this file and make sure to comment out the rest to not break a JavaScript syntax. And then, using require node option, we can import this file and its content will be executed.
Yeah, I guess we have seen this already on our previous stream on the Beyond XSS blog series. He also shown that you can also pollute that prods environ file with JavaScript code, and then you can place the reverse shell there. So that's kind of, I got to say, this is top-notch security research what we're currently seeing.
And that's the final payload.
Okay, he's just showing the reverse shell. And then he's also showing on the server itself, when you load the canvas, that malicious JavaScript will be injected into prod's environment, and you will get a connection back to your netcat listener. Yeah, right here. This is really good.
Was just checking if the variable has its own property, so that the property of proto is never used. The vulnerability was patched in Kibana 5.6.15 and 6.6.1. Not only this attack was super cool, but also the way it was exploited might allow to turn any attack when you control environment variables in Node.js into remote code execution. So if you feel like you've learned something new today, like the video and leave a subscription.
Yeah, I really like all of his videos, and I'm already subscribed, so I recommend doing the same. Like the amount of effort actually took into this video, like showing from like his own site, the visuals and everything are extremely good, even though it's like that was one of the first videos when he was starting out. It was good quality one, sure. So yeah, and if you want to explore the material, if you want to read yourself as well, you can also check this page. So, and for the last part, I guess we gonna check for the last part how you can use it for the mass scale, how you can like try to detect prototype pollution in the wild, how it says basically. If you are not doing white box, so I guess this gonna be for the white box, but um, if you want, you can try to do this as well. So this is also pretty good read, like many people do recommend checking this as well. So let's try exploring this. Okay, prototype pollution is an interesting vulnerability. Either it is server-side or client-side. Based on the application logic, prototype pollution leads to other vulnerabilities. For instance, POSIX introduced an interesting technique to achieve RCE in template engines. Mikhail Bankovsky showed bypassing client-side HTML sanitizers, and William Ballings found reflected access on HackerOne prototype pollution. Yeah, so we already seen those. From RC to SQL injection, SQL missed the small I. Any vulnerability is possible with prototype pollution in JavaScript application. All right, everything is possible. Got to appreciate that paint skills. Okay. In this research, our goal was simple, which is to scan all vulnerability disclosure programs for prototype pollution and find script gadgets to achieve an XSS. So yeah, this is really interesting area. If you discover some new research, people are like exploring new bugs what were like introduced like couple years ago, it is really good idea to try to read yourself, try to reproduce like bug bounty reports did as well, and then try to maybe like try mass detecting them on the most vulnerability programs, because if they exist somewhere on one program, it could also mean that there is potential to be replicated somewhere else as well. All right. This technical write-up will touch the tools we created, the challenges we faced, and the case studies during the whole process. A lot of people are involved in this work. It was really a great experience working with these super awesome people. All right. Okay, I see the research team consists a lot of people here. That's really interesting, and like those are security researchers who made this possible, like introducing prototype pollution vulnerability, and the research team are like a lot of people, I gotta say. So number of vulnerable libraries found, so I guess they were searching for vulnerable code mostly. Number of bugs reported to vulnerability disclosure programs, around 80. Okay, so they were hunting for VDPs. Not sure if they also checked bug bounty programs. We found numerous, more than 1,000 websites vulnerable to pollution. We haven't reported them because of not having gadgets or VDPs. If you don't want to know the methodology, feel free to skip to the case studies, real bugs. I like to see about methodology. This is really interesting. Okay, so what they were using to detect those vulnerabilities: Selenium bot, browser extension, CodeQuell query. So CodeQuell is actually, you can describe certain like using certain code, how you can mass detect vulnerabilities in different libraries, especially if they are being used open source in the GitHub for the most part, I guess. So they're using CodeQL. That's kind of interesting. And I think for Selenium bot and browser extensions, they were just targeting certain websites, which is also like alternative method. So they are using from the white box perspective and from the black box perspective. Identifying the vulnerable library. So the keyword search. So they were looking for certain sync functions, probably browser debugger with conditions, so using developer tools. So as there were a lot of people working on this, I think some of those people were using one method while others like using different method, and they were collabing. So in that case, I guess most of those techniques were like different for each member. Blocking JS file request in the browser to find vulnerable one. All right. Then finding the script gadget in the vulnerable library, keyword search and source code review. All right, so we were doing keyword search again. Security MBs, pollute.js, like he created burp add-on. Let's see. Pollute.js. Okay. Let's see. Okay, so there is actually the burp suite extension just for checking the prototype pollution. So one of those researchers actually created the extension where you can like check for those. File descriptors, untrusted types, browser extension. So file descriptor even created the browser extension, and then like reporting, store vulnerable library gadget database. So they also used, I guess, for like resource sharing, they used some kind of database to share information between each other. Source code search on public www.com. Yeah, this is like really good website. If you are doing security research, I could really show you. I guess this one. Yeah, you can, for example, if you found a vulnerable WordPress plugin, right? And if you want to find most of the websites, what you can do Google Dorking, or you can like browse through like a lot of files of many top websites. So for example, if I just type VP plugin, it will give me some kind of query and some kind of code. Like they will have different snippets for VP JSON, like VP blah blah blah. We can target like different stuff, but I don't want to like skip way to like stay too much on this website just to show you the functionality of it. You can explore yourself. It is pretty powerful if you decide to do security research or like hunt at the mass scale. If you find 0-day, this could be one of the websites where you can like discover this. Not only use like Nuclei with Axiom and stuff like that, but you can also check this, or like also doing some Google Dorking. All right. Source code, regexx in burp passive mode. There are a lot of ways to do that. All right. Detection. There are two cases when we were interested in the web application to check if it's vulnerable to prototype pollution. Okay, case one. In the first case, we want to check if an application is parsing query hash parameters and check if it's polluting prototype in the process. We found that 80% of nested parameter parsers are vulnerable to prototype pollution. That's crazy number. Oh. Okay, let's assume that the web applications use CanJS deparam library to parse a query parameter. So yeah, I guess just using this website if you discover vulnerable library, and if you know how that file of that library, like JavaScript file, is called, you can just type that JavaScript file. If they are not using custom name for that file, we are probably doomed. And if they're using vulnerable version for that JavaScript file, that could be seriously good area to research this. Alright, so feel free to explore the public www website. It's pretty powerful, I gotta say. Alright, so let's assume the web applications use this library. As you can see the code below, it creates an empty object and adds key value pair. Obviously this leads to prototype pollution if we requested the URL like this, like using proto as the parameter, like writing to the value admin as 1. So this one will be polluted. And right here, if we write to the console, like after polluting the value, you can set up, like upgrade your privileges to admin if those are being used somewhere on the JavaScript. I guess if it's being used by Node.js, it could be more interesting, but I highly doubt that someone uses a client side for like checking the admin. Not sure. Proof of concept, query parsing. As you already guessed, it's easy to identify if application has vulnerable prototype pollution parsers by iterating over different prototype pollution payloads in location hash and location search. Following are the different variations of query string which may be parsed leads to the pollution. So there is just like different payloads that could be used to detect the pollution. Okay, so Selenium bot. To automate this, we wrote the Selenium bot that runs a huge subdomains database and checks if application is vulnerable. So I guess they wrote the custom code using Python, and they are using a lot of servers for this type of attack. What you can do, for example, if you create this type of custom script, you can, for example, spin one server. On that server, install all the dependencies, including the Selenium, like Chrome driver, Python like required versions, Python libraries. Test on that one website if everything is working fine, like for like maybe just a couple of websites. If it's working, what you can do to scale is like do the snapshot of that server and use Axiom, like create custom module and then use like at mass scale multiple servers and like split the URLs across those servers, and it will be really good security research. If you don't know what I'm talking about, if you're new about like how Axiom works, I have a lot of different blog posts about it. Just feel free to search, like the links are in the description. If you don't know where you can find my website, just check the links. So yeah, you can use Axiom for that with even like Selenium, but you have to like create custom stuff. Like here, for example, they actually created different payloads. Those are just payloads, those are just the return functions, and those I guess what it's has to detect. There are actually right now a nuclei template to detect prototype pollution. Well, you can use nuclei as well if you don't want to install Selenium, but I guess they just use this just for more convenience. Not sure if this will work better or not, but you can try both of those methods for sure. So it will just open the domains and it iterate through the domains, and it will iterate through the payloads, and it will have some kind of between each of requests, it will have timeout of 5 seconds. It will use Selenium driver to access the URL plus the payload, and will also do other timeout, like 2 seconds here. Current URL, and also in here they will check if they can get the URL or not. If in that case, we'll try executing the script. Okay, they are just automating the browser stuff here. So, but right now the Nuclei is pretty powerful. You can do most of the stuff like on the browser automation there as well. So you can use the headless mode and you can do many things there as well. But yeah, as I said, like you cannot be 100% guaranteed that it will work only like using Nuclei. Okay, so that was just Selenium bot, how you can massively test the stuff. I guess one of the researchers or maybe a couple of researchers were doing that, but there is an alternative way using browser extension. One issue with the bot, but we can scan directories and authorize endpoints if the application, because the database becomes very large and it takes days to scan. Most programs prohibit scanning. Okay, to overcome this issue we wrote Chrome extension with same logic as the bot, but it scans when user visits particular endpoint in the Chrome. Using the extension we can casually use Chrome in the background and it scans for prototype solution. Yeah, so this is, I guess, passive scans or something like that. Not actually passive scans, but if it does in the background, maybe it's kind of interesting. I can actually remake this to be possible on Firefox. So let me know if you want. I can like spend some stream like remaking this, but yeah, this is kind of interesting. You can like upload custom plugin to do this in the background. So okay, let's explore case 2. In this case we want to check if there are any functionalities where the user input or some data response processing in the client side leads to prototype pollution. Most of the time this leads to self-access because the attacker can't control the input, as in case 1 where input comes from the location. Yeah, this is worth scanning, but it's worth scanning. Most of the time self-access can be converted to reflected access, and if you followed some security researchers or bug bounty hunters, you can also convert self-access to like some more serious stuff. If you can, for example, find SRF, you can chain this with self-access and it will be way more higher severity than like this one, informational one. This case it is a little challenging to automate. Fortunately CodeQuell made things easier. We've chosen only highest paying and the top programs and dumped all the JavaScript files and created CodeQuell database and scanned for the patterns that lead to prototype pollution. Okay, CodeQuell. So this was actually also pretty smart way. I haven't actually done much of the research how this works. For me, I guess it's kind of, my brain hurts when I try to review CodeQuell how it works, like all this documentation. I'm kind of used to black box more, maybe, even though I was developer, but CodeQuell, not sure. Maybe for some people it might be interesting, but not for me. We've chosen only highest paying top, yeah, and they were actually not hunting on all of the programs, and dumped all JavaScript files and created CodeQuell database scan. Oh, so they were just using custom rules, and we were just scanning the JavaScript that they have gathered actually. So they have gathered the JavaScript also using some kind of mass scanning as well, maybe like different servers, not sure. We haven't actually explained this, but I'm just assuming that what we are doing. We were able to find one application where user control JSON is matched with another one, which leads to prototype pollution, and we scored a nice bounty for XSS. Okay, identifying the vulnerable library. Once the bot identifies the vulnerable application, our next task is to identify vulnerable library and the exact line where prototype is polluted and store the result in database. So like the amount of effort multiple people when they are collaborating, like a lot of smart people were collaborating into one project. Like I really like how they handle everything. They like actually using the same database. They are actually doing a lot of research. I really appreciate, like, this is really interesting way how security research could be done. To identify, we use few different techniques. If the application is not complex, searching for keywords like location hash, decode URI component, location search, that search in Chrome developer tools will result finding exact functionality of vulnerable implementation. Okay, blocking the JS resource request in Firefox. There is nice option called block URL in Firefox developer tools network activity. So to find JS resource which is responsible for prototype pollution, we block the URL and check if polluted property is undefined. If it's undefined, we can confirm the blocked resource is responsible for pollution. Okay, they are just using the Firefox functionality. All right. Debugger on breakpoint on setter. This technique is easier than others. We can set the breakpoint when the property is set to object prototype. Not only object prototype, you can actually try on other areas probably. Okay, script gadgets. What is script gadgets? Certain properties polluted, application logic or functionality can cause the JavaScript execution. Let's see the example of script gadget we found of fifth type search library. The payload to achieve XSS is example proto alert 1. Okay, the below is the piece of code. Script gadget is responsible for popping alert. Search iterates over this. Use server configuration. Install hooks object along the properties on prototype, which leads to our polluted property XXX being evaled. Okay. Based on the application, we've used different techniques to find the script gadgets. Okay, so what? Keyword search and source code review. So those like one of the techniques how you can find those. If the application is simple, we can search keywords like source, doc, inner HTML, iframe, create element, and review source code and check if it leads to JavaScript execution. Sometimes mentioned techniques might not find gadgets at all. In that case, pure source code review reveals some nice gadgets like below example. Oh yeah, we are doing plain source code review. That's kind of crazy as well. Black fan found this tool gadget in jQuery source code review. Oh, jQuery. That's really cool. Okay, so they were like importing the jQuery code and then they were polluting object prototypes of like prevent default function, handle objects, and delegate target. Document of foobar. Here is the piece of code which is responsible for the gadget, which is self-explanatory. So there is a actual code of jQuery where it like shows the vulnerability. Okay, pollute.js. We had written burp extension around security MB's pollute.js, which replaces all JS resources with modified version generated by the pollute.js. Also, we modified pollute.js to log information only if certain property is polluted. The basic idea of pollute.js is it instruments the code by adding the bugs function around all the property access, which logs exact line of access when the object prototype is accessed. I might use this extension as well to my security tool belt, I guess. So yeah, it's gonna be probably kind of useful, just in case, you know, my burp suite in the background detects this. So yeah, that's pretty interesting. Check the add-on below. No, the add-on is not perfect, so they're just showing the code of this. Okay. File descriptors on trusted types of I really like that they are actually putting all the researchers' different approaches to one article, so in this case you can like explore yourself and decide like which approach you want to test for yourself as well. This is really good. I like that. Okay, let me check quickly. Cool. All right, so if you visit this GitHub page with add-on installed, you will notice an inner HTML sync in jQuery. Here wrap map tag is undefined, which means they can pollute li property of wrap map with an array and the first and second element injected to the page. Okay, so they were just injecting through the value of the URL using a debugger. So they're just polluting li property here, right here, and this is the value of that property with JavaScript alert. Okay. Once the gadget is found, we report the bug to the respective program. Store vulnerable libraries and gadgets in the database. This like used one database. Let's see. Code quell. There are a lot of things to see. I want to see if they're... Oh, the case studies are actually the reports they've written to the different companies, and they actually allowed to disclose that for sure. In Jira Service Management, in those versions, they had prototype pollution, they had backbone query parameters, which were vulnerable to that. So on mouse move, okay, so we are just like using user sign up, for example. Okay, in jiramozilla.com we found an XSS also on the via the URL. So I guess from those kind of reports they've written, you can see that mostly they were polluting via URL attack vector, but it doesn't mean that there will be all the cases. As we've seen on the parts figure, there are 2 more cases where you can do this. XSS on apple.com. Oh, nice. Apple.com pays really well as well. We're discussing ways to test unauthenticated endpoints. We finalized creating Chrome extension. Can use wrote basic Chrome, basically checks for those 2 payloads and checks if prototype polluted. Okay, we quickly found. Then they also bypassed the fix. HubSpot Analytics. Oh, we got 6k bounty for reflected access. I guess for the quality report they received this for sure, because that was not only like a regular access, they did a lot of research, so in that case it was worth 6k. HubSpot Analytics. Yeah, so there are a lot of things I really like. I see upvote. Only 1 response? Seriously? This is really good. Why not too many people are seeing this. I think I gonna share this on my X profile for sure. Alright, for those who are still watching the stream, thank you a lot. I know this is really complicated topic, not for everyone, so it takes, you have to rewatch over and over and over to understand everything correctly. What I suggest you to do is also try exploring those topics yourself, try to read until finally you understand how it works. At the base level, for sure you have to know a little bit about programming, like how inheritance works, like basics about JavaScript. But it's, as you can see, this could be really interesting vulnerability to explore. If you like trying to do security research, maybe this could be interesting topic for you. So yeah, this was really good. And like, yeah, what I recommend, if you are like participating in bug bounties but you're like not getting enough out of it, like eventually for some people, I not want to say that it's meant for all people, but for some people doing security research would pay more than doing bug bounties. So you can consider like picking certain topic like this, for example, prototype pollution, and doing some research yourself. And in that case, it could pay even more than like picking one program and sticking to it. You can do this as well. This is like alternative way. So yeah, it was like brief overview about this type of vulnerability. On the next stream, we're gonna explore different one. So see you tomorrow, and hopefully everything's gonna be all right. Have a nice remainder of the day.